Hi everyone, this is our lecture on naming covalent compounds. So here are the steps on how you would name these compounds. So sometimes they're called molecular, sometimes they're called covalent. So just be mindful that those mean the same thing. So first thing you're going to do is name the first element first using the entire element name. The second is use the root of the second element and add "-ide" to the end. And then use prefixes to indicate the number of atoms of each element. So this one's a little bit easier, I think, when we name these compounds because they're pretty straightforward about how many atoms are present. Unlike ionic compounds, we just use the element name without really, indicating how many atoms there are. But for covalent compounds, it's a lot easier. So here are the prefixes that we are going to use. So you might have encountered these before in a math class maybe, right? 1 means mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca, right? So these are the prefixes that we're going to stick in front of each of our element names to indicate how many of each there are. So here's practice. You can watch this first one if you'd like, or if I were you, I would pause, right, and try it on your own using those steps. So pause right now. Okay, so hopefully you've tried these on your own. So let's go over the answer. So we know this compound to be carbon dioxide, right? We talk about it all the time. But why is it called carbon dioxide? So if we were using the steps mentioned in the first slide, you're going to name your first compound, which is C, carbon, right? And then you're going to name the other compound and then use the suffix "-ide." So there it is, "-ide." And then we have oxygen. So the root word of oxygen is oxy, right? Oxy. But then to add the "-ide, you have to just get rid of the rest and then put that there. And then this di right here indicates that there's 2 carbon dioxide, which is right here, right? 2 oxides or 2 oxygen, right? Next one. Hopefully you said sulfur dioxide. So same idea. Sulfur, right, only has 1 atom, so it's just sulfur. And then oxygen, one more time, has 2, so it's di, and then the suffix "-ide." So you might be wondering, well, what about mono, right? Because if we go back, if we go back here, 1 is mono, right? What about that? So we only put mono, you guys, on the second element, and we'll see an example of that later on. So like if, for example, we say CO, right? CO is carbon monoxide. So same thing, right? Carbon is right here, and mono means 1 oxide. So instead of being carbon dioxide, which has 2 oxygens, it's just carbon monoxide. So the mono only works for the second element, not the first one. So we're not going to call it monocarbon monoxide, right? It's just carbon monoxide. Okay, next one. Hopefully you said nitrogen trifluoride, right? So there's that tri there indicating the 3. And the next one is carbon tetrachloride, so tetra indicating the 4. So like I said, right, see how all of the beginning elements is just their regular name, right? Because there's only 1. Now, if there's more than 1 atom for the first element, then that's a different story, right? But these are just all, there's only 1 carbon, 1 sulfur, 1 nitrogen, and 1 carbon again, right? But you can add prefixes to those as well if it applies. It's just in this example, they don't apply. Awesome. Next one. Now we're going to go backwards, right? So pause first. Okay, now we're going to go backwards, right? So pause first and try it on your own. And then when you're ready, go ahead and hit play. Okay, so here we go. First one is tribromine nonooxide, right? So tri hopefully tells you that's 3. Bromine, you're talking about bromine, right? And then nano, right? Nano, hopefully you'll tell me is 9, and oxide, as we've talked about, is O. So once we put that all together, your answer should be Br3O9. Right? Next one is nitrogen dioxide. Same thing as carbon dioxide, NO2. Right? Here's the di right there. Oh, and going back to what I was telling you earlier, right? So see how this one says tribromine, because this times there's 3. Whereas here nitrogen just stays nitrogen. It's not mononitrogen, right? Because it is the first element being said, right? Next one is pentaoxygen dichloride, right? So pent hopefully tells you that that's 5. Oxygen, di, 2 chlorines, right? So O5Cl2. And then last one is diboron heptaoxide. And hopefully you'll tell me that's B2O7. Right? So again, I feel like this is a little bit easier in terms of naming, just because the name literally tells you how many, as opposed to ionic compounds where you have to think about valence, you have to think about, okay, well, how many of this would cancel out the charge. I feel like this one's a little bit more straightforward. Okay, now we're going to talk about binary acids. We've also talked about that in the ionic sense, so it's about the same, just a little bit of tweaking. So here are your steps. The first one is add hydro as a prefix, and then the root word with the ic ending, and then the second word being acid. So every single acid ends in acid. So here's an example, HCl. So the first thing we're going to do is we're gonna add hydro as our prefix. That actually signifies the H, right? That signifies H. And then the root word of the elements, our element is chlorine, but we have to add the ic. So that's chloric, right? And then second word acid. So our answer would be for this one, hydrochloric acid. Right? Nice and simple. Now, this is a different one. So notice this one is oxyacid. I forgot to point out. Binary acid, remember, binary means 2, right? So binary acid means you have 2 atoms, usually an H and then something else, right? Your H is the trick. It's the shortcut to knowing that this is an acid, right? You'll see things like HBr, right? That's hydrobromic acid. But usually your clue is if there's an H is an acid. This one is different though, oxyacids. These are the ones we also talked about in ionic bonds. This was a little bit complicated in terms of naming. So this table, you might have seen it before. We've used it before. It's in your textbook. You have to find your point of reference. So in the ionic lecture that we had, right, we usually just change the ending to 8 or ite, depending on how many. So if you have 3, right, or that's the most that your element can hold, then it's 8. And then if it has less than that, then it's ite, right? So using that information, here is an example, right? So this one also on your textbook, in your textbook, but here are the steps. So it says the acid with 1 more oxygen than the ic acid, right, is called per blank ic acid, right? The acid with 1 less oxygen than the ic acid is called blank us acid, and the acid that has 1 less oxygen than the us acid is called the hypo blank us acid. So a little harder to visualize when it's just a bunch of words and blanks, right? But this is what we're talking about. We're talking about these ones, right? So for example, it says the acid with 1 more oxygen than the ic acid is called per ic acid. So here's our ic acid, chloric acid, and it has 3 oxygens. If we had that, which is 1 more than the ic acid, then this compound is called per chloric acid. That's what that means, right? And then this one says the acid with one less oxygen than the ic acid is called the us acid, which we already have. It's right here, chlorous acid, right? That's one less than the ic because it only has 2 oxygens, right? Now, if we had one more, which is one less oxygen than this, that would look like HClO, just O, because we don't write the 1, right? So this particular compound would then be hypochloric acid, right? So that's what that means. It's having this range of more or less. And your trick, again, is figuring out what is my ic and what is my us using the oxy ions, right? So here it is, the example I just told you, right? This is the one straight from the chart, the ic acid and the us acid. If you have +1, which is 4 of the ic acid, you have per chloric acid. If you have one less than the ic acid, then it's chlorous acid. And you have one less than the us acid, then it's hypochlorous acid. So this one, you really have to think about, what is my ic acid? And to figure that out, right, then you have to do the Lewis dot structure. Eventually, as you get used to it, you'll see it right away that that's the ic acid. You'll memorize it. But for now, you just have to think about, okay, if I were to make this into a compound, right, how many of each would I need? Pretty much is what that means, right? So here's another example. So try it out first, pause it, and then we'll do it together. Okay, so hopefully you've tried it on your own. So let's go ahead and answer it together. So again, the first thing is to figure out what is my ic acid, right? And these are, hopefully you've figured out that these are polyatomic ions. So on your list, you should be able to find these easily. So here are all the answers. Per sulfuric acid, we have sulfuric acid, sulfurous acid, and hyposulfurous acid. So if you're going into this and you're like, well, how do I figure out what the ic acid is? So what I would do is I would look at your polyatomic ion list and then look for these ions, right? So I'm looking at one right now, and in my list, hopefully you have one handy. In my list, SO4 2- is sulfate. And then I have SO3 2- is sulfite, right? Remember that the sulfate ions always change into sulfuric, right, where the ic is, and then the sulfite always changes to the sulfurous acid. Sorry, I ran out of space there. But the ates, right, and the ites always change to that. So that is your clue. Look at your polyatomic ion list. And then from there, again, you go one up, then you get per sulfuric acid. You go one down from the us acid, and then you get hyposulfurous acid, right? I just want to let you know that not every question is going to be in this table. So I might just straight up ask you what H2SO2 is. And in your mind, you might have to make this table and say, okay, well, I got to find the 8 ion, turn it into ic, and then how many levels down is that to get to H2SO2, right? So it is kind of a process, and it does take a little bit of practice to do these oxyanions. So here you are again. Like I said, here's your giant hint. You need to be familiar with the 8 ions, right? And you can use this as a scheme to name any oxy acid. So all of these are 8. So if I were to change all of this over to the next step, it would be ic, right? So ic. So we'll have sulfuric, we'll have chloric, we'll have phosphic, right? Nitric, bromic, and then carbonic, right? And then from there, again, take a look at your subscripts there. From there, you can go up or down, and you should be able to figure out which is the, per sulfuric acid, which is the sulfurous acid, and which is the hyposulfurous acid. I would suggest to try these on your own for more practice. This page is in your book, 209. I like this diagram because it helps you see, right? Kind of, it's like a flow chart of steps, right? You look at the formula, is it acidic or not? And again, acidic is usually the one with H's. So if you say yes, then you're going to go this way, right? If you say no, you're going to go the other way. So it's just a good way to really organize your thinking, right? Because I'm not going to put all of these in categories, right? I'm just going to jumble up all of these compounds and I'm going to tell you, name it, right? So it's good practice to use this chart while you have it, because on the test you won't be able to use this. Okay, hopefully that made sense. If you need more practice, let me know. We are going to practice quite a bit for this one.